Before you start lesson 21, make sure you complete test E in the test masters, and it deals with circles. Also, make sure you've completed investigation 2. It starts on page 110 about using a compass and straight edge. Those investigations are very important for you to do. Those are good hands-on activities, good hands-on applications of math. Lesson 21 has 2 parts, and the first part is on prime and composite numbers, and the second part is on prime factorization. Best way to think about prime numbers is that they only have 2 factors, 1 and the number itself. Those are the only 2 factors that they have. So try to remember that a prime number, 1 and the number itself are the only factors. Let's just look at these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now the prime numbers that we have there, 1 is not a prime number. Let's just circle the ones that are prime numbers. Remember, the definition of a prime number is 1 and the number itself are the only factors. So basically there's 2 factors. 1 is just 1. Doesn't have 2 factors to it. So we don't consider 1 a prime number. 2 would be a prime number. 3 would. 4 is not, because you could do 1 times 4, and then you can also do 2 times 2. So there's at least 3 numbers there that are factors. And so 3 is a composite number. 5, that would be a prime number. 6 is not. 7 is. 8, 9, and 10 are composite numbers. They're not prime numbers. So another way to think about it is if you're trying to compare prime and composite, prime have 2 and only 2 factors, 1 in the number itself. Composite numbers have at least 3 factors, 3 or more factors. That's how you define a composite number. For practice, why don't we go ahead and try to write the first 10 prime numbers. Why don't you go ahead and pause the CD and try to figure those out on your own, and then turn the CD back on and check your answers. Now the safest thing to do, I think, is just to go ahead and write down a bunch of numbers and then go back through those and circle the ones that are prime. That's the safest way to not skip anything. You can do it in your head too. You can just start counting 1, 2, 3, 4 and just write down the ones that are prime numbers as you go. But sometimes it helps just to have them all out there to look at, and then you can do some division in your head and say, oh, well, is this one divisible by a 2 or 3 or a 4? And then figure out if it's going to be a prime or a composite. Remember, 1 is not a prime number. 2, 3, 5, 7, all of those are. So we have 4 that are prime so far. 11 is a prime number. So is 13, 17, and 19. So now we have 8 prime numbers. We need 2 more. 23 is a prime number, and 29 is a prime number, divisible by 1 and itself. Or in other words, 1 and the number itself are the only factors. Remember, we kind of think of factors and divisibility interchangeably. All of the other numbers that I have listed there, except for 1, of course, those are all composite numbers. They all have more than 2 factors. Well, now that you know the difference between prime and composite numbers, let's talk about prime factorization. And think about the word prime in there. You know what a prime number is. Factor, you know what a factor is. That's a number that is used in multiplication. And prime factorization, let's just use an example. Let's take 20. What you're going to do is break 20 up into all of its prime factors. So we know that 20, let's just say that equals 10 times 2. That's one way we could write that. And that's not broken up into prime factors, though. 10 is not a prime number, but 10 can be broken into 5 times 2, right? So we could say 2 times 2 times 5. Now that's the prime factorization of 20. Now you might be wondering, why would I need to write the prime factors for a particular number? What importance is that? Well, you'll see real soon it'll help you reduce really big fractions. Remember, we learned about reducing fractions in lesson 15. You will apply what you're learning here to reducing fractions in lesson 24. Let's look at a little bit bigger number and do something called a factor tree. Let's look at 300. And let's break that up into prime factors. Now what you do on this is just think of two factors that you know, if you multiply them together, would equal 300. Like you could do 10 times 30. It doesn't really matter what you pick to start with. But you know those are two factors of 300, but those aren't prime numbers, are they? So you need to break those down smaller as well. So 10, we can break that into 2 times 5. 30, we can break that into 6 and 5. And then the 6, we can break that into 2 and 3. Now, wherever we end on this tree, those are the prime factors that we multiply together. So this number, this one, this, and this, those are the prime factors. Now let's just rewrite this. Let's write them in numerical order. It doesn't matter. You don't have to do it that way, but let's just go ahead and do that. It just kind of looks nicer. You have 2 2s, 1 3, and 2 5s. And there's the prime factorization of 300. You can go back and check your work if you want to, and you'd see that you have 5 times 5 is 25, times 3, that'd be 75, times 4 does equal 300. So if you do the factor tree method, you use the last entries in any branch of that tree. Those are all the factors. Another method for a big number is just dividing by prime numbers, because you know then that you definitely have a prime factor. If you divide by primes, let's just use 300 as an example again. We could do 300 divided by 2 since it's an even number, and then we'd get 150. Divide that by 2 since it's still even, and we would get 75. Now let's divide that by 5, and we would get 15, which we can divide by 5 as well, and we would get 3, and 3 is a prime factor, so we're done. And again, we can just write all of these factors down. 2 times 2 times 3 times 5 times 5. Maybe what you'd want to do is do just the division by primes method as well as the factor tree. That's a way you could check your work, make sure you did it right. Or of course you can always just multiply all the prime factors together and make sure you get back to the original number. Look at practice problem B. I want you to write the prime factorization of 96 and use the factor tree method to do this one. Don't use division by primes, use the factor tree method. So let's just break this up. And again, it doesn't matter what two factors you start with. I know that 96 is equal to 12 times 8, so I'm going to use those two to start with. And then I can break 12 into 4 times 3. 8 can be broken into 4 times 2. And then the 4s can be broken into 2 times 2. Now, be careful on this. Remember, the last entries in any branch, those are your prime factors. So this 3, this 2, and these 4 2s, those are all the prime factors. Now just go ahead and rewrite that. 2 times 2 times 2 times 2 times 2 times 3. 5 2s times 3. That's the prime factorization. Then of course you can always check your work to make sure that's correct, and this one is correct. If you multiply that back out, you will get 96. Look at practice problem C. I want you to use division by primes to figure out the prime factorization of 318. Now we know that's an even number, so we know 2 is going to be a factor, but let's just use some of our rules for divisibility, our tests. Remember, if you add up the digits and it's divisible by 3, then that number is divisible by 3, or 3 is a factor. So look at that. We have a 3 plus a 1, that's 4, plus 8 is 12. 12 is divisible by 3. So we know that 3 is a factor. Let's just go ahead and do that division. And we'll say that 3 goes into 3 one time. And we'd bring down a 1. 3 goes into 1 0 times. There we have 18. And we'd have 106 as our quotient there. So 3 is a prime factor. Then we'll take the 106 and break that up. And we know it's an even number, so we'll divide by 2 there. And we'd end up with 53. 53 happens to be a prime number. So our answer is just going to be 2 times 3 times 53. Now on most problems that you'll be using this for, you kind of decide whether you want to use the factor tree method or the divisibility method to figure out your prime factors. Okay, well that's all for lesson 21. If you need some more practice, there's the practice problems in the textbook there, as well as supplementary practice problems in the appendix for this particular lesson. So if you need even more help, go there, and don't hesitate. If you're struggling, first thing you can do is rewind the lecture and watch it again to see if you can get it down. If you still need some more practice, do the ones in the textbook, and if you need more after that, do those practice problems in the back. Sometimes doing a whole bunch of them at once, that really helps you get it down good. And you want to be able to do this quickly and easily. That way, when you use it coming up in lesson 24, this part won't be a problem. You won't have to relearn prime factorization. You'll just be able to jump right in and do the lesson easily. Okay, well that's all for lesson 21.